Okay, so this one, again, not very difficult because, why did I put an equal sign here? Because, this one satisfies your basic strategy, remember, is to let, typically u is going to be your inside. So here you have an inside. And then what you want to kind of make sure is when you get the derivative, if you're going to get the derivative of that inside, is its derivative also in the integral somewhere. And so, will you say, yeah, right? Because if you let u equal y squared plus 5, the derivative of that is 2y dy, and you have that right here. You have a y dy, so all you need to do is multiply by a 2, and then you'll divide by 2 on the outside. And so, easy peasy, no problem. Here we have, this is du, and so when I rewrite this, this is going to be 1/2 the integral of, here I have u to the 8th du. Oh, du was supposed to be green. Sorry. Okay. So then this is just equal to 1/2 times u to the 9th over 9 plus c. Or u is y squared plus 5 to the 9th over 18th. And that's it. Okay, so in this one, you ask yourself, okay, do you have a part of here where its derivative is also inside the integral? Well, yeah, right, because the derivative of, if you pick u to be this inside part of the function, 1 plus 2x cubed, its derivative is equal to 6x squared, and you have a x squared right here. Sorry, dx. So all you need is the 6. Well, that's easy to deal with because you just multiply by 6 and then divide by 6. So hopefully, this is revealing kind of a pattern where, typically you have the inside part of a function, and then what allows you to use integration by substitution is that the derivative of that is on the outside. And again, it isn't always how it works, but this is the most obvious case when you would use integration by substitution. Okay, so then if I continue, I would have 1/6 the integral of u to the 2nd power du. And this is equal to u to the 3rd over, I have this 6 here and then over 3. So when I multiply those together, it's going to be 18 plus c. And so then I get 1 plus 2x cubed to the 3rd over 18. And that's it. Oh, plus c. Don't forget your plus c's. Okay, so this one is a little trickier because it just looks kind of funny, You have this natural log in here. Usually that makes us a little nervous, but think about, your basic strategy, and remember that typically you had the inside part of your function be u. So let's say we just try that. Notice that the derivative of natural log is just 1 over z dz, but whoa, look at that. That's right there. This exactly how it is without making any changes. That's equal to du, so it actually isn't very difficult, right? So then what we have is, this is ln of z is u squared. And then now here you have to be careful. This isn't, du isn't going to go on the bottom. Sorry, it's a terrible color. Du goes on top. So this right here, this is dz over z, or 1 over z dz. And so this is equal to du. So du is going to go on the top. That's really important. Should never have du on the bottom, ever. If you have du on the bottom, then you can't do anything. Either you did something wrong or I don't know what happened. Who knows? Anyways, then this, the antiderivative, is u cubed over 3 plus c, or natural log of z cubed all over 3 plus c. Okay, so we're increasing the level of difficulty every time. When you're looking here, notice there's no inside here, you know, that kind of helps you. But you look for, does a part of this, its derivative also exist inside? And you go, well, yeah, right, because you can let u be y squared, and its derivative is 2y dy. And that's right there, but that's not exactly correct, because let's say you try this. So you would need a 2 here, right? Because you need the 2y dy. So you would bring the 1/2 on the outside. But notice that what would happen is you would then have 1/2 the integral. These would be du, and then over, this would be u plus 4. And, well, that's not very good. I mean, I don't know how to find the antiderivative of that. So can you see a simple modification that you can do to this to for it to give you a better situation when you substitute? Well, if you said, why don't we make u equal to y squared plus 4, you would be exactly correct, because, bam. Because notice that when you get the derivative of y squared plus 4, the derivative is exactly the same. So du doesn't change. Du, that yellow color is terrible. Let's do mustard. Okay, du doesn't change. It's the same. But what does change is it makes the denominator, it's going to now be simply u. Only u. That's it. It's just u, because u is y squared plus 4. So you swap this entire thing for u. And so now this one we can find the antiderivative of. This is 1/2 times the antiderivative of du over u, or also you can think of it as 1 over u. That's natural log of the absolute value of u. And so this is equal to 1/2 natural log of the absolute value of y squared plus 4 plus c. Sorry, I forgot the plus c here. And if you want to, in this case, you can get rid of the absolute value, because y squared plus 4 is always going to be positive. So you don't really need it. But it's also not incorrect to leave it there. And that's it.